Hi guys, welcome back. So we are now on differentiation. So today I'll be giving you a lot of formulas you have to know in your head before the next video. So you have to know all these formulas in your head before the next video. So like I said, before you can pass maths very well, you must know nothing less than 70 formulas offhand. You must know nothing less than 70 formulas offhand. Sure you get. So if you want to pass maths very well, all those formulas must be in your head. So today, these ones too, you must add it to the ones you know in your head. So now I'll explain all these formulas on the board. I'll explain everything. I'll explain to my best understanding how you can put it in your head without cramming. I wrote everything offhand. So I want to teach you also how you can write it, how you can be able to know it offhand without cramming. You don't have to cram. These things are very, very simple. So I'll start with the standard derivative form. That's the first thing. I'll start with the standard derivative form. This is all I have. There are more than that though, but at least let me just start with all this. So the first thing I'll be starting with, these are the derivative of everything you see here. Everything you are seeing here, this is the derivative of everything. You have to know it offhand. There's proving for everything, but you just have to know it as a constant. You have to know it offhand. There's proving for everything. Sure, you understand? So, but you just have to know it offhand. So instead of, when they ask you, instead of you proving it, just give them the answer direct. So the first thing I'll be starting with is the formula, which is, let's say we have ax raised to power n, and you are told to differentiate y in respect to x. You know, when they say differentiate y, we call it dy dx. So it means we are differentiating y in respect to dy dx. In respect to x, that's why I'm saying everything here are the dy dx, are the derivative. So the first thing is the formula. I don't even know where I'm to right now. So the formula is what? Ax raised to power n. Let's say we have ax raised to power n. What is the differentiation all about? The power of that x will multiply the constant down, then subtract one from the power. That's all about differentiation. The power will come down, then you subtract one from that power. So that will be what? N multiplied by a. Shall you get? Then x raised to power n minus 1. That's just all about the formula for differentiation. Shall you understand? So, for example now, let's say we are given y equals to 3x raised to power 4. 3x raised to power 4. Now, how do you differentiate? We are differentiating y in respect to x. So once you want to differentiate, we call it dy dx. And what is it all about? What do we say the formula is? The power will come down and multiply the constant down. Then you subtract one from that power. So what's our power here? 4. That will be 4 times 3. Shall you understand? Then x raised to power 4. You subtract 1 from that power. That's 4 minus 1. So that will be giving us 4 times 3 is what? 12x raised to power 3. That's 12x cubed. That's just all about the formula for differentiation. So that's just all about the formula. So the second one says, when you differentiate a constant k, I'm using my constant as k here. When you differentiate a constant, you have 0. Let's try it. Let's say we're told to differentiate y equals to 5. Y equals to 5. You know there's no x there. And we are differentiating, don't forget we are differentiating in respect to x. So meaning that what is the power of x here? It means that the power of my x here is what? 0. Because x raised to power 0 will go, x raised to power 0 is 1. 1 times 5 will go back to 5. Since I'm not having x. So what will you do? That will be dy dx equals to, what's the power here? That will be 0 times 5. X raised to power 0 minus 1. 0 times 5 is what? 0. X raised to power 0 minus 1 is minus 1. 0 times x raised to power minus 1 is still what? 0. Can you understand? That's why when you differentiate a constant, you have 0. When you differentiate a constant, you have 0. Please take note. Anywhere you differentiate a constant, you have 0. Either you differentiate 10 is 0. Either you differentiate 1 is 0. Either you differentiate 2 is 0. Either you differentiate 100, it is what? 0. Now, the third one. Yeah, this is where we are going to now. When you differentiate sin x is what? Cos x. When you differentiate sin x is what? Cos x. But when you differentiate cos x is what? Minus sin x. Sure you understand? When you differentiate, I'll explain how you get it. When you differentiate cos x is minus sin x. When you differentiate tan x is what? Sec square x. When you differentiate sec x is what? Sec x tan x. Sure you understand? When you differentiate cot x is what? Minus cosec square x. But when you differentiate cosec x is what? Minus cosec x cot x. Now, okay, let me now explain this part for you. Just this part alone. Sin and cos, take it like family. Sin and cos, take it like family. Tan and sec, take it like family. Then cot and cosec, take it like family. I'm trying to give you the way that you don't have to cram. Just know this logic in your head. Sin and cos, take them like family. Tan and sec, take it like family. cot and cosec, take it like family. When you differentiate sin x, you have cos x. But when you differentiate cos x, you have minus sin x. I'll tell you why that one is having minus. I'll tell you. When you differentiate tan x, you have sec square x. But when you now differentiate sec x himself, you have sec x tan x. I don't know if you are flowing. You don't have to cram, just flow it like that. When you differentiate cot x, you have minus cosec square x. And when you now differentiate cosec x himself, you have minus cosec x cot x. Another thing you have to take note of something. Anywhere you differentiate anything starting with c is differentiation. I not say integration. Anywhere you differentiate anything starting with c, you have minus. Anywhere you differentiate anything starting with c, you have minus. Let's check. When you differentiate cos x here, what do you have? Minus. Cot minus. Cosec minus. Cos here minus. Cot here minus. Cos inverse minus. Cot inverse minus. You see that anywhere you differentiate anything starting with c, take note of it. Anywhere you differentiate anything starting with c, you have minus. So sin and cos, take it like family. When you differentiate sin x, you have cos x. When you now differentiate cos x, starting with c, you have minus sin x. Differentiate tan x, you have sec square x. When you now differentiate sec x himself, you have that sec x and tan x. When you differentiate cot x, you have minus cosec square x. When you now differentiate cosec x himself, you have minus cosec x cot x. Shey you understand? Please, you don't have to cram, just know it like that. Now, let's go to exponential x. When you differentiate exponential x, it's still the same thing. You have exponential x. But when you differentiate exponential kx, what will happen? The constant will come down, then raise to power that constant. That will be k exponential kx. If you have exponential minus kx, you have what? Minus k will come down, the constant, minus k exponential